Today we are going to start limiting reagent. The limiting reagent concept used, I would say, in almost of chapters of physical chemistry, the limiting reagent used. Okay, let's talk about limiting reagent. Let's talk about limiting reagent. The reagent which is completely consumed in a chemical reaction is called limiting reagent. The reagent which is completely consumed in chemical reaction is called limiting reagent. What does that mean? What does that mean? Understand? Let's see. I'm taking simple example for limiting reagents. Let's try to understand. Yes, I'm taking, for example, A plus B. It gives AB product. AB product. Yes. A is 1 mole, B is 1 mole, and AB is the 1 mole. AB is the 1 mole. Yes, initially 1 mole of A, 1 mole of B, it gives 1 mole of AB product. Okay. See, after some time, A reactant is decreases. How much decreases? It 1 mole. Okay. If B is the 5 mole, B is the 5 mole. AB is how many moles? AB is how many moles? How to decide? How to decide? Based on limiting reagent. Based on limiting reagent. See, for example, a reactant is 1 mole completely consumed in the reaction. So it is completely consumed means this is the limiting reagent. Yes, which is completely consumed. Which is completely consumed. Completely consumed. That is the limiting reagent. Yes, here 5 moles are there. How much is left? How much is left? It is 5 minus 1, 4 moles left. Yes, 4 moles left. 4 moles left. It is a excess reagent. It is an excess reagent. Okay, how many number of moles product to form to decide limiting reagent? Okay, so first of all, we know the rules for finding the limiting reagent. Okay, now what are the rules? Okay, rules are tricks. Okay, let's discuss the tricks for the limiting reagent. Let's move on. See, the very first, balanced chemical equation. Balanced chemical equation. Write the number of moles of reactant and the product in given equation. That is the first one. Second one, write their stoichiometric coefficients in chemical equation to write the stoichiometric coefficient. The third one, divide the number of moles upon stoichiometric coefficient. The third one is number of moles upon stoichiometry. The fourth one, the reactant which is minimum of this ratio that is the limiting reagent. The reactant which has minimum value, that is a limiting reagent. Okay, now the divide the number of moles and stoichiometric coefficient, we are getting the value. That value is the minimum or least, that is the limiting reagent. The final, we can do the mole analysis. Mole analysis. Yes, these are the rules for to find the limiting reagent. Yes, we can move next. Try to understand with the example. Okay. Yes, if I am taking example and I am taking example, see 2A reactant plus 3B reactant to give 4C products and 5D product. Yes, 2A plus 3B, it gives rise to 4C and 5D. Yes, see, in this chemical equation is balanced. Okay, I am balanced the chemical equation. I am taking general equation. At initially it's how many number of moles? I am taking initially, it's taking 4 mole. Okay, na? It's take 9 mole initially. See, reactant, it will be 0. It will be 0. Yes, it will be 0. Let's find the limiting reagent given equation. Okay, let's find the limiting reagent in a given reaction. See, for example, 2A reactant. What is the stoichiometric coefficient is 2. In B, what is the stoichiometric coefficient is 3. Okay, for example, 2A 3B. Okay, A reactant is stoichiometric coefficient is 2 and B reactant stoichiometric coefficient is a 3. Yes. Now we are taking number of moles 4 moles and the number of moles B is the 9 moles. See, moles upon stoichiometric coefficient. Yes, number of moles. So A is the 4 moles upon stoichiometric coefficient is 2. So the value, what is the value? Its value equal to 2. Yes, its value equal to 2. Next, taking B. See, number of moles 9 moles. Number of moles is a 9. Stoichiometric coefficient is the 3. This value is 3. So the ratio of reactant which is least, the 2A is the least value. 2A is the least value means that is the limiting reagent, which has higher value, that is the excess reagent. In this given equation, what is the limiting reagent? A is the limiting reagent, B is the excess reagent. Yes, B is the excess reagent. Okay, so the limiting reagent decide the number of products is formed. Yes, so let's start. After some time it's 2A, it is completely consumed means 0. 2A is the limiting reagent that is completely consumed, that value will be 0. Yes, 0. How many number of products are formed? See, how many number of products is formed? D. Okay, let's, by using the limiting reagent, we can find the number of moles of C and number of moles of D. Yes, let's, for example 2A. See, 2A moles, it gives how many moles? 4 moles. 2A reactant gives how many moles? 4C. Yes, 4C. If I am taking 1A mole, how many number of moles of C is formed? 2 number of moles of C is formed. Okay, what is the value of limiting reagent? 4 moles. I am taking 4 moles. How many number of moles of C? It is 2 into 4. It becomes 8C. 8C means 8 number of moles. The C is the 8 mole. Yes, the C is the 8 mole. Yes. How many number of moles of D is formed? How many number of moles of D is formed? Let's take D. Okay. See, 2A reactant to give 5D. Yes, 5D. I am taking 1A moles. How many number of moles of D? It is 5 by 2 D mole. 5 by 2 D mole. Yes, but the limiting reagent is 4 moles. I am taking 4 moles of A. 4 moles of A. It gives how much? 5 by 2 into 4. Yes, it becomes how much? 10. It is 10D. Yes, 10D. 10D moles is formed. It is 10. It is 10. Okay. See, the limiting reagent to decide the products is how many moles? 8 moles. D how many moles? 10 moles. Okay. What is the remaining part? How many number of moles of B is reacted? How many number of moles D is reacted? Yes. Let's calculate B also. Let's calculate it. B also. Let's, for example, 2A react. See, let's 2A reactant. 2A reactant means 2A react with how many moles? 3 moles of B. 3 moles of B. I am taking 1A mole. 1A mole. How much? It is 3 by 2 B mole. Yes, 3 by 2 mole. But we want how many mole? 4 mole. 4 mole. How many moles of B? It is 3 by 2 into 3 by 2 into 4. It is equal to how much? It becomes 6 moles of B. 6 moles of B. Yes. See, 6 moles is completely consumed means it is 9 minus 6. Yes, 9 minus 6 means how many moles? 3 moles, or 3 moles are still left in the container. 3 moles still left in the container. Still left in the container. Yes. This is the way to calculate the limiting reagent and find out the number of moles of products consumed in the chemical reaction. Okay, let's take, I am taking one problem about limiting reagent. Yes, can go to next problem. Yes, for example, see, write the question. Lithium hydride, see, like 6 moles of lithium hydride react with 8 moles of boron trifluoride. It gives how many number of moles? It gives how many number of moles? See, 6 moles of, sorry, 6 moles of LiBr4 plus B2H6 diborane. Okay, on starting with 2 moles of each reactant, 2 moles of each reactant, 2 moles of each reactant, how many moles of B2H6 can be produced? That is our problem. See, how many moles B2H6 can be produced? Yes, first we can do what? We can write the balanced chemical equation. Okay, I am writing the equation. See, 6 moles of LiH treated with 8 moles of boron trifluoride. It gives 6 moles of LiBr4 plus B2H6. Look at this. How many number of moles? 6 moles. How many number of moles? 8 moles. See, let's, on reaction starting with each reactant, how many moles are involved? 2 moles. At 0 time, initially, how many moles? 2 moles. Yes, 2 moles. This is also 2 moles. Initially, the product will be 0. Initially, the product is not formed. Yes. See, after some time, see, after some time, how much reactant? Let's find the limiting reagent. Which is limiting reagent? So, lithium hydride is there and boron trifluoride is there. Lithium hydride is a 6 and boron trifluoride is a 8. So, stoichiometric coefficient is a 6. See, number of moles, it is 2 moles. Stoichiometric coefficient is 2. It becomes 1 by 3. Yes, 1 by 3. 1 by 3 means it becomes 0.77. Right. Next, number of moles of BF3, 2 moles. Yes, stoichiometric coefficient is 8. It is 1 by 4. 1 by 4 means it becomes 0.25 mole. 0.25 mole. In these two, which is least value? 0.25 is the least value. That is the limiting reagent. Other one is the excess reagent. Yes. Okay. So BF3 is the limiting reagent. LiH is the excess reagents. Okay. Limiting reagent means it is completely consumed. Consumed means it is 0 mole. See, let's move on. Find the how many number of moles of B2H6 is produced. Okay, let's move on. How many number of moles of B2H6? For example, the relation of 8BF3, 8 moles of BF3, it gives how many moles of B2H6? 1 mole of B2H6 is consumed. Okay, 1 mole. See, 8 moles BF3, 1 mole. See, I am calculated about 1 mole. Yes, 1 mole. How much is consumed? 1 by 8 into, sorry, 1 mole na? See, 1 mole. Yes. One by 8 mole. So what is the limiting reagent? 2 mole. 2 mole means 1 upon 8 into 2. It becomes 1 by 4. 1 by 4 means it is 0.25 mole. 0.25 mole. See how much is formed? 0.25 mole. Yes. Next. This is over. Let's find the number of moles of lithium bromide. See, 8 moles of BF3. It gives how much? 6 moles of LiBr4. Let's 1 mole how much? It is 6 by 8. 6 by 8. Yes, LiBr4. But limiting reagent how many moles? 2 moles. 6 by 8 into 2. Yes, it becomes 12 by 8. It means it becomes 1.5 mole. 1.5 mole. How much? 1.5 mole of lithium bromide and 0.25 mole of diborane B2H6. Yes. How many number of moles can produce B2H6? 0.25 moles. 0.25 mole. I am calculated lithium hydride also. How to calculate lithium hydride? Let's move on. How to calculate lithium hydride? How many number of moles? See, let's move on. See, 8BF3 react with 6 moles of lithium hydride. 6 moles of lithium hydride. I am calculated 1 mole react how much? 6 by 8 mole lithium hydride. Yes, but limiting reagent is 2 mole. How much is 6 upon 8 into 2? It becomes 3 by 2 means it becomes 1.5 mole. 1.5 mole of lithium hydride. Yes, so 1.5 mole of lithium hydride means, see, 2 minus 1.5, it becomes 0.5 mole. 0.5 mole still left in the container. 0.5 mole left in the container. Yes, this is a way to calculate the limiting reagent. Okay, thank you.